Okay, now I try to summarize what we have learned from the first section of chapter 7 about identity, trigonometric identity. So I try to connect with all of the definition of trigonometry we learned from chapter 6. Okay, so now the reciprocal identity means sine of theta equal 1 over cosecant of theta. Where this come from? So let's see, we're going back to definition of trigonometry, definition number 1. So we have the angle is a acute angle in the right triangle. So we decide the ratio of this length here over this length here. We call it sine of theta. Sine of theta equals the opposite of theta, the length of opposite theta over the length of hypotenuse. Cosine adjacent over hypotenuse, tangent is opposite over adjacent. So now sine equal opposite over hypotenuse equal 1 over hypotenuse over opposite, which is equal 1 over cosecant theta. So now the definition here is cosecant theta equal h over o, and secant of theta equal h over a, and cotangent of theta equal a over o. So this is just a definition. We don't have to prove anything. We name the ratio of 6 ratio between all the sides in the right triangle. So give the name. So from that name, we see that sine is reciprocal of cosecant, and cosecant equal adjacent over hypotenuse equal 1 over hypotenuse over adjacent, which is equal 1 over secant of theta. This one here is secant of theta right there. Tangent the same. So tangent equal opposite over adjacent equal 1 over adjacent over opposite. This one here equal cotangent theta. So this is the first very fundamental identity, basic identity for trigonometry. This comes from the first definition of trigonometry. So now the next one we call rational identity. So now rational identity, we say tangent of theta equal sine over cosine, and cotangent theta equal cosine over sine. We can use this property to divide the ratio of tangent theta, but I prefer to refer to the definition 2 of trigonometry. So this one here is the circle with a radius r. Okay, so the point x and y here is the point on the angle we call the angle in standard position. Start from here. This is an angle theta we're talking about. Okay, so angle theta here. So this one radius equal r. So we have a definition like this: sine theta equal y over r, cosine theta equal x over r, tangent of theta equal y over x, and reciprocal, of course, you're going to have cotangent of theta equal x over y, and secant theta equal r over x, and cosecant theta equal r over y. So we have this definition. Now that different from here is we will not talk about triangle anymore, right? This on the coordinate x and y on the r in this circle, radius r. So but you still can imagine this one x here, y here, right? So now, so tangent by definition equal y over x. Okay, y over x from the second definition of trigonometry. So but how to turn into y? So now, if sine theta equal y over r, right? Therefore, y has to be equal r sine theta, and x here equal r cosine theta. Then you plug it in. R sine theta divided by r cosine theta. Cancel that one. So we can see that tangent theta equals sine over cosine. And because this is reciprocal of the other, and equal 1 over sine theta over cosine theta, therefore equal cosine theta over sine theta. Okay, this one rational identity. This one reciprocal identity. Next one. The third one, the basic identity, fundamental identity. This one, the second one. The third one is Pythagorean identity. Okay, the Pythagorean identity probably the most important because after this you use this one to divide a whole lot of different formula in the future, like the sum, half angle formula, things like that. So the whole one of them rely on this. Without Pythagorean, we don't have that kind of formula. Okay, so first of all, Pythagorean identity starts from here. You have x squared plus y squared equal r squared, right? So that is the formula for the circle, Pythagorean. So then we know that y equal this and x equal this, so we change to r cosine theta square plus r sine square equal r square. Now we distribute the r here, r square cosine theta square plus r square sine theta square equal r square. Simplify. So you cancel, you divide everything by r square. R square divided by r square equal 1, not 0. Okay, you cross it out and say, oh, this one gone, right? No. Okay, 1 still there. So we have cosine square theta plus sine square theta have to be 1. Okay, if you want to test the formula, you can put any number in here regardless. This one number is rational number. I mean the degree number, everything. You can put any number here and here. Okay. Okay. So now I have the number one identity here is sine square theta plus cosine square theta equal 1. Okay. You can put your graphing calculator or calculator, you put any number here, 5.71 can be degree or radian, doesn't matter. You square it because no matter where the angle here in radian, whatever, x squared plus y squared always equal, sine square plus cosine square always equal 1. So number 1. Now, from number 1, we derive another formula. So randomly, you think if you divide everything by cosine square, right? For example, then you create another Pythagorean identity. You divide by cosine square theta, cosine square theta, cosine square theta. So what do you have? A sine square plus sine square, okay, sine over cosine equal tangent, right? We use this one connect to the other one. So then you have tangent square theta plus cosine square divided cosine square equal 1. Now 1 over cosine square equals secant square. Okay, by keep deriving formula consistently, you will remember all this one, and the next one connect like a chain, the chain, of many links together. So if you do back and forth and you keep all the links, if you don't do that, some link broken and you get lost. Okay, so we keep doing this. So number 3. So if you divide by sine square theta, so instead of cosine square theta, now we divide by sine square theta, and sine square theta. What we have? Sine square divided by sine square equal 1. Cosine square divided by sine square equal cotangent square. Finally, 1 divided by sine square equal cosecant square. So we have the 3 of Pythagorean identity based on the first one is the unit circle. Okay, the formula for the unit circle and also come from the Pythagorean. Okay, next we talk about odd and even function. So from chapter 2 we already know if f is even, f of minus x has to be equal f of x. Okay, if f is odd, f of minus x equal minus f of x. So now we even and odd. Okay, so cosine even is even because cosine negative x equal cosine x. For example, you check cosine negative 30 degree has to be equal cosine 30 degree, right? Which is in quadrant 4, in quadrant 1, the x is still positive, so both of them come out to be root of 3 over 2. So therefore, secant also the even, secant even because secant is reciprocal cosine. Okay. So the rest is odd. Okay. Sine of x is odd because sine of minus x equal minus sine of x. For example, sine of minus 30 degree equal minus sine of 30 degree. So sine minus 30 degree equal minus 1/2 in quadrant 4. So equal this in quadrant 1 equal 1/2, but then minus outside here. Here is the meaning is when you change x from positive to negative, the value of y doesn't change. And here, if you change the value of x from positive to negative, the value of y here change from positive to negative. Okay. So when you look at the graph and you understand a lot better, for example, cosine even look like this, cosine like this, right? When cosine 30 degree equal root 3 over 2, right? When you get negative 30 degree, also root 3 over 2. So this one reflect to the line y-axis. Okay. Meanwhile, the odd function behave differently. You look at the graph of HQ is a graph of function here. Okay, that's the graph of HQ. So now reflect to the point of origin. So you put here, for example, you pick any point from here, you go to here, go the same distance, you get this point, right? Here, you get the same distance. So go to here, you get the same distance, and go here, get the same distance. So then you connect all the points together. So this one represents an odd function. Or also, you want to see the function sine. The graph of sine look like this. You have from here, let's say you have this and this and this, so you get a function like this, right? Okay, so now you look at that, look at this. So you have the point here, you go to here, you get this point, right? You go to here, you get this point, you point to here, you get this point, here, you get this point, and the point here, you get this point, and you go to here, you get this point. So you connect all together here and then reflect this one to the origin. Then you go keep on like here, from here to here, you know, from here to here, and from here to here, and from here to here. So you keep going like this, so you have this part here reflect to that part. This on the odd function. Okay. Now, yeah, we review the odd function from algebra perspective, and now we look at for trigonometric perspectives for the odd function. Okay, so tangent is the odd function based on the graph you see, right? Also, tangent of negative 30 degree equal minus tangent 30 degree, right? Both of them negative number, right? So sine odd, therefore cosecant odd because they are reciprocal to each other, and tangent odd, therefore cotangent also odd. So you have two even function and 4 odd function for trigonometry. Okay, finally, cofunction. Okay, so now first of all, which one is cofunction, which one, and what does it mean? So I have sine theta. So cofunction of sine theta is cosine theta. Okay, we shortcut cosine theta. You see, very easy. Sine, cosine, secant, cosecant. Okay, so if I put secant here, cofunction should be cosecant, right? But I prefer you do backward like this. Cosecant theta is the cofunction of secant of theta, and tangent of theta, cofunction of tangent theta equal cotangent of theta. Okay, now look, why arrange this way? This one is cofunction. Okay, this one cofunction. This one is cofunction, and this one is cofunction. Okay, but this one is reciprocal. This one and this one also reciprocal to each other. Only this one both cofunction and reciprocal. So that's why I organize this way. You can see the whole thing about cofunction, about the reciprocal function. Okay, what mean by cofunction? Here, cofunction comes from the definition of the triangle, or the trigonometry of the right triangle. Okay, take a look at this. If this one is theta, so this one should be 90 degrees minus theta, right? So if I have sine theta equal all over h. So now how about cosine of 90 degrees minus theta? Sine theta equal this over this. Cosine this angle here equal adjacent of that angle over it. So equal all over h. So they are the same. Sine theta equal cosine 90 minus theta. So now you have to say equal now. Okay, to make sense what means the cofunction equal cosine pi over 2 minus theta. Cosecant theta equals secant of pi over 2 minus theta. Finally, tangent of theta equal cotangent of pi over 2 minus theta. All these things going to be very important for the next lesson. The next